Okay, so this is a lecture on relevant feedback. So kalau I want to summarize this session is that when we try to find for certain article, we type in a keyword in the Google kan. So once we type in the Google, so if we found that no relevant document ataupun tidak banyak dokumen yang relevant, we try to adjust the keyword. We try different keyword kan. Okay. So this session will look at the process of how do we adjust the query, and the better query that we key in will direct us to the right document. So we will look at the process, how do we the calculation of finding the relevant document towards the keyword that you key in. Okay, how actually they make it happen. Okay, so that's why this is what they call it relevant feedback. Relevant feedback meaning that we giving input in order to we giving input as feedback to the degree of relevancy of our document. We adjust the query, we adjust our keyword in order to get a better result. So the query expansion referring to that is the process of modifying the query. We expand the query or we change the keyword that we use. So that is the process of modifying our query. Okay. Okay. For example, like this, the Google suggests us the query expansion. So this is based on the hit, number of hit, or popular keyword that being used. So they will adjust. They will suggest to us. Okay. And the process of finding the right document is based on this. We put our initial query, and then we search and we perform the ranking. The system will search and perform the ranking, and they will display n rank document, contohnya 20 atau 30. Okay. So then we give the feedback by clicking on the document. So by clicking on the document, so the system will know that, okay, since you click that document is relevant to the keyword that you have key in. So they will keep your history. So that is the kind of feedback that we provide to the system. Okay. So yang modern punya method lagi, they look at our eyes where we focus, then without even clicking, they will anticipate that, okay, since we are looking at that particular link, so they assume that that link is important with respect to the query. Okay. So once the given document we have gone through, then we adjust the query again, and then they will search and perform the ranking and display to us. Then we click again. Okay, so that is the process of query expansion, and at the same time also we give feedback to the system which document is relevant with respect to the keyword. Okay, so this is the whole process lah. Okay, so for example, this is our query, initial query. So dia ada di sini. Tapi yang relevant document tu is here, and this is not relevant. So our objective is when we expand the query or if we modify the query, we want to move this one move towards here. Okay, and assume that the top 4 nearest are yang dekat-dekat dia tu lah. So our objective is when we want to expand the query or modify the query, we want to move that point to the positive one. Okay. So that is we reformulate lah to move that to a closer to the positive one. Okay. So two basic approach of feedback method is they call it explicit feedback. So we provide the feedback through survey. Okay. Or implicit means automatically the system will capture based on where you see and what you click. Okay, so two different things. Explicitly, they are based on survey or based on Q&A. And implicit is automatically captured by the system. Maybe depends on where you click or where you see. They look at your eye movement. Okay, so there are a few methods on how do we measure the relevant feedback. So we have a framework. So we have a set of documents, DR, that are known to be relevant to the current query. So the relevant feedback, the document DR are used to transform Q into a modified query. So meaning that depending on the document, the relevant document, they will modify your query. Okay. So in a framework, we could look at the document they have clicked on. So this is implicit. Or we look at the term belonging to the top of the document in the result, meaning that you have a list of document given to you. So they will look at the keyword that belong to the top document. So for example, like this, they will give you this. This is a suggestion. Okay. Okay. So like I mentioned just now, the explicit you get from the survey. The implicit one you get from the system where they capture the feedback automatically. Okay, and then they will determine how to transform your query based on the information you give to them. Okay, so this is your initial query. So they will move your query closer to the relevant document by suggesting to you the list of query that you could take. Okay, in an explicit relevant feedback. So this is very time consuming because you need to do the survey. You need to maybe you need to ask volunteer, and then you ask them, and then you take survey. So this is a very expensive and time consuming. So the easiest way is you look at the click, where they click, and then you will capture the information that is relevant to the concept that they are looking at. So this is you put up the query. This is explicit. So this is explicit. So this is the result, and the you tell us where is relevant document with respect to the query. So we capture the information manually. Okay, and then you modify again, and then the process is over and over again. Okay, so this is relevant feedback. Another one is that based on the click that you have, then you will modify and so on and so on. So the first one is the user tell which one is relevant. The second one is based on the click only. Okay, So the first one is called relevant feedback, and the second one is called click feedback. Okay, so another one is the implicit one. So the implicit one, we have local and global analysis. The local analysis looking at the feedback information from the top ranked document. So we will look into this. The global one is derived from the feedback information from Thesaurus. So we'll cover this one only. So for example, this is you key in the query. This is the result. And based on the results that we have, we will perform local analysis. And then the user will modify the query and you get new result. For the global one, the same thing, but we use Thesaurus to change the query. Banyak terlari ini. Let me fix this one first. Nanti you bingung. Okay. So the difference between the local and global, local use the algorithm design in the IR system itself. But for the global one, we are referring to some external tools that we use in order to perform the analysis. Okay, let's take a look at the first one, explicit relevant feedback. Okay, when we're reading any document, normally we highlight the important concept or the keyword that is important to describe the particular document. So similar to this, what they do is they select important terms that can be used to represent the document. Okay, so with this keyword, they will have a list of keywords. And then when we type in the keyword, they will suggest to us all the list of possible keyword that is popular. Popular in terms of the number of hits is high for that particular keyword. Okay. So we have one technique. They call it Rocchio method. In the Rocchio method, what happens is that we are trying to modify the query in such a way that it will move towards the relevant document. Okay, and the formula is looking at these two methods. So they are saying that with the Rocchio method, we try to reformulate the query in such a way that it will get closer to the neighborhood of the relevant, but away from the neighborhood. Okay, so remember the process of yang tadi tu. This one. So the objective of the query transformation is we want to move the location of our query to be closer to the relevant document, which is here, and away from the non-relevant document. So that is the function of the Rocchio method that we will be looking at now. So that is this one. Okay. So this is the X is non-relevant and the 0 is non-relevant document. So the initial query here is this one. So what we want to do is we want to move closer to the relevant document. So from the initial query, we revise the query. So the query will move us to the nearer to the relevant document. Okay. So what is the formula? So the formula is given this is your relevant document, and you know the size of your relevant document 10K, 20K, and then you also have the non-relevant document, and you also know the size. So these are two different things. But when you try to retrieve document, it may consist both of these, relevant and non-relevant document. Okay, so the green one is the retrieve one. So and you also know the size. Okay. Um, so here is maybe this is the set of all relevant documents. So yang ini yang kena retrieve, yang ini yang relevant document retrieve. This is non-relevant document retrieve. Tapi yang tidak kena retrieve tu yang the remaining maybe here. Okay. Okay. So based on this scenario, they say, okay, how do I move from one location and then towards the more relevant document? Okay, so consider that we have the CR. So CR is what? So, CR is set of relevant document. So we have set of relevant document that being retrieved. Okay, being retrieved, the CR. Okay, so the query optimization is that what I want to do is from all the retrieved document that I want to get away from the non-relevant document. So that's why I am trying to minus this from, okay, N is all the number of document in the collection. So this is all the remaining document which belong to non-relevant document. So this is not belong to relevant document, meaning that they are not relevant. Okay. So kalau I try to draw them is that, okay, this is my retrieve relevant document. Okay, so this is the retrieve not relevant document. So this is my query. Okay, no, not my query. This is the direction of the relevant document. This is the direction of the non-relevant document. Okay, so since my formula here is that I'm trying to minus all these things, all the non-relevant from my relevant. So I will have to minus lah. So this is the direction of positive. So if I take that, this minus this, so it will have to go to this way lah. And for that, my query optimization will be here. Okay? But if I have a query, banyak titik ni. Okay, if I have a query, so this is my query, and my query should be aligned to my relevant document, so this one. Okay, but I want to minus this, so I minus this, so this is my modified query. Okay, Okay, so that is the process here. I have my query, and this is what given. Okay, this is what given, and then I want to minus whatever I have in the non-relevant document. Okay, so how are we going to apply this concept in trying to modify our query? Okay, so this is our formula. So remember that this is the relevant document. This is the non-relevant document. Okay, normally when we have this, so this is the same here, and also this is the same. So they have a constant value that we have, the beta and the lambda here, and also the alpha here. So this is they have constant value. So we will apply this value as a constant value that we have. Okay. So you have learned about TF-IDF, kan? Okay, so let's suppose we have this document. So the red denotes non-relevant. So this is not important, and this is important. Okay, so we want to compute this one. Okay, so this one is easy. We just referring to this one, and this one is just taking the average, and this one. Okay, so if you plug in the value, okay, so this one we add up together and divide by 3. This is divide by 3. Yeah. So similar to this, we take the average. Okay, we take the average, then we get this. So this portion is relevant. So relevant is the blue one. This is non-relevant. Okay, so we just plug in the value. So we just plug in the value there. So meaning that we perform the formula here. Okay, so our query here, and then the modified query will be this. Okay, so this is our name. Okay, and this is the second one, the relevant one, and this is the non-relevant. So when we perform the calculation, we will end up this one. So this is the modified query that we have. Okay, so meaning that we know the content of our document. So based on the query that we have here, I will transform them to be like this. So it will be nearer to the relevant document, but away from the non-relevant document. So we make use of the TF-IDF, and we use the Rocchio method in order to transform our query. Okay. So this is the exercise. So don't worry, I will pause up this one. So given this queue, we have this. So similar to the same exercise just now. So you just have to compute the modified query using the formula that we have here, this one. Okay. We will stop here. So you will be expecting 2 more assignments. One is on the precision and recall, and the other one is this one, Rocchio method. Okay, you still there? Sunyi sepi ni.
Fokus.
Okay,
Macam bingung.
so don't worry, you slowly digesting this one. Lucky